In this lesson, we will implement a restaurant rating system using the single layer neural network we've been working on for a while. This system will evaluate the restaurants based on three criteria. They are food quality, atmosphere, and service. We will use the same code we used in the last lesson. However, there are two additional sections. First one is preparing the training data. Here we will see how to represent text using binary data. And after the training, we will make a script to rate the restaurants using the trained network. I think you are very excited about this lesson. Let's get started. We will prepare the training data now. For that, create a new folder, name it Restaurant Rating. Then create an Excel file in this folder, name it Training Data. Open it and click on Format as Table. Choose this style, press OK. This heading will be sequence of the training data. Then take another heading. It will be food quality. Next one is atmosphere. Then service. And finally the rating. Creating the dataset for first restaurant. Say the food quality is bad, atmosphere is bad, however, service is good. Overall rating should be bad. For second restaurant, the food quality is bad, the atmosphere and service are good. Food is the main fact, so I like to rate it as bad. Now the food quality of the third restaurant is good. Atmosphere is bad. And the service is good. In this case, we can assign good rating to it. The fourth restaurant has good food, good atmosphere, and good service quality. Of course, the rating will be good. Notice carefully. The three evaluation criteria and rating of four restaurants have been represented by two values only. They are good and bad. Let's set good equals 1 and bad equals 0. Alright, our training dataset is ready. This is the same dataset we used in the previous lesson. However, in this time, these 1s and 0s have other meanings. 1 means good and 0 means bad. Now launch the MATLAB. Click here and go to the desktop. Here is our restaurant rating folder. After selecting it, click on Select Folder. Now click on New Script. Save it as Training Script. Create a variable named Input. Now start copying the training data from the Excel file and paste them here. There will be a semicolon after each row. Copy the second row and paste it here with a semicolon at the end. Now the third row. Copy and paste the last row. Terminate with a semicolon and a closing square bracket. Now create another variable named correctOutput. Then type equal and take a square bracket. Now copy the ratings from the Excel file and paste it here. Let's organize them in a single line. Now take the closing square brackets and the semicolon. So these are the training data and these are the corresponding correct outputs. Rest of the codes is exactly as same as the code of previous lesson. I have already explained them in details there. That is why I'm not repeating the same details again. Creating a single row matrix of random variable. Then initiating a for loop. It will iterate for 40,000 times. In every iteration, it calls a function named function rating. It returns updated weight every time we call it. It requires weight, input and correct output as input arguments. That's the end of the for loop. Now click on this plus symbol and save it as function rating. At the first line, I'm defining the function. Then setting alpha equals 0.9. Initial weight will be a single column matrix of all zeros. Now set n equals 4. Then initiate a for loop. It iterates for n times. Then transposing the rows of the input matrix. Calculating the weighted sum by multiplying weight and transposed rows. Output will be processed weighted sum returned from sigmoid function. Now storing the corresponding correct output in D variable and calculating the error by subtracting the output from correct output. Calculating the delta using output and the error. Now getting the modified weight. Now adding updated weight to the modified weight. And that's the end of the for loop. Now measuring the average weight update. And finally, updating the weights which will be returned by this function. That's the end of this function. This function requires sigmoid function. Let's create that. Click on plus symbol and save it as sigmoid. Defining the function at the first line. It calculates and returns 1 over 1 plus e to the power minus x. That's the end of this function. Now create a new script and save it as testing. Copy the input data from training script and paste it here. Change the variable name to testing data. Let's move them here and terminate it with a semicolon. Set n equals 4. Then initiate a for loop. It iterates for n times. Every time it transposes the rows of testing data, then multiplies it with the weight, which we get after training the network. The final output will be returned from sigmoid function. Input to this sigmoid function is the weighted sum. That's the end of this for loop and also the end of this script. So far what we have implemented is exactly what we did in the last lesson. Now the fun part starts. We will modify this code to save the trained network. Then we will create another script which will use this network to rate restaurants. Get back to the training script. Looks like a semicolon is missing here. Added. Now we want to save the trained network. To do it, we have to use MATLAB's save function. I'm saving this network as weight.mat. You can use any name you want. However, make sure that you are using .mat extension. Now run the code. Here is the saved network. Let's test the network and see if it is working properly. We've got the correct outputs. That means the network is fine. Now click on this plus symbol and create a new script. Save it as restaurant rating. Write clear all at the first line. It will clean the variables from the workspace every time we use this script. Now we will load the trained and saved network. For that, create a variable named network or anything else you prefer. Then use MATLAB's load function to load the network. The name of the network is weight.mat. Let's see what do we have inside this network variable now. Type CLC in the command window and press enter. The command window will be cleaned. Then run this script. After that, type network in the command window and press enter. These are the things we have inside this variable now. We want this weight only. Other things are not necessary. To get the weight only, create a variable named weight or whatever name you like. Then write network. After that, type a dot to access the object inside of this network. We want the weight, so type weight. Run this script. Type weight in the command window and hit enter. Now this variable has the weights only. When this script runs, we want to know the opinion of the users about food, quality, atmosphere, and service. To do it, we need to prompt the question on the monitor. Take a variable named prompt. Then inside opening and closing single quote, type food quality, good or bad. Then create a variable named food quality. Use MATLAB's input function to take input from the users. The input function will prompt the message we have in the prompt variable. Add this S here to store the user responses as they are. The users will write good or bad. However, our neural network accepts only zeros and ones. At the very beginning of this lesson, we said good equals 1, bad equals 0. Remember? If the user type good, then we will convert it to 1, and if they type bad, it will be converted to 0. To do it, we need to use an if condition. In the expression of if condition, we will compare users' input using STRCMP function. This function compares two strings and returns 1 if they are same, otherwise it returns 0. If the input is good, we assign 1 to food quality, else we will assign 0 to food quality. Let's see the STRCMP function in action. In the command window, type STRCMP, take same string and hit enter. As both of the string is same, it will give logical 1. Now type two different string and press enter. It will generate logical 0. This is how STRCMP function works. Let's get back to the script. This time we will ask question about the atmosphere. Type prompt equals atmosphere, good or bad. Then we will take the user's response using input function and we will store it in ATM variable. Then if the user input is good, we will set ATM to 1. Otherwise, ATM will be 0. In the same way, we will take user's response for the third question. It is service good or bad? If the service is good, then set service to 1. Otherwise, service equals 0. Now, using food quality, ATM, and service, we can create the decision matrix. Let's take a variable named decision matrix. It is a single column matrix. The rows will have the values of food quality, ATM, and service quality. Let's run this code and see what is happening in this decision matrix. In the command window, the script is asking for user's response. Let's say food quality is good, atmosphere is good, and service is also good. Based on this response, the decision matrix has been generated. Let's run this script again. This time, set everything to bad. We have got a decision matrix with all zeros. That means decision matrix is working properly. Now it is time to use the trained weight to rate the restaurants. First we need the weighted sum. Take a variable named output to store the weighted sum. The weighted sum is actually the multiplication of weight and the decision matrix. The final result will be the value returned from the sigmoid function when the input is weighted sum. That means the output variable. Now run this script. Let's set all response to good. We have got the final result. It is a fraction of 0.99. It does not represent the rating system the way everyone will understand. We need to modify the final result a bit to make it a perfect rating system. Take a variable of any name you like. I'm naming it rating score. Then multiply 100 with the final output. Take another variable named showScore. Now using MATLAB's STRCMP function to generate a string. Now type with me. The rating score of this restaurant is %.f. Here this %.f is to discard the number after decimal point. And it will show the number stored in showScore variable. Finally, using the disp function to show the string on the monitor. Now run the code and provide responses the way you want. The rating score is 1 out of 100. Indeed, a poor restaurant. Let's try some other combinations. This time rating score is 100. Must be a very good restaurant. Checking another combination. Another good restaurant. Run the script again and try some other combination. The score is 45. That means a regular restaurant, not so good, not so bad. So we know the theoretical concept of single layer neural network. We have implemented the concept using both SGD and batch method, and we just have applied the batch method in this lesson to make a restaurant rating system. I think you are now confident enough to build your own single layer neural network. However, before going any further, I must have to disclose that single layer neural network is not a good choice to solve real-world problems. In the next lesson, we will see the limitations of single layer neural network, and as usual, I will explain everything in details. I hope you will join in the next lesson.